Hello, this is Britt Castle with another example video. In today's video, I'm covering example 5 from section 4-3 in the SavvasRealize Algebra 2 textbook. So the goal of this example is to learn how to divide rational expressions. So what I want us to do is I want us to go back to, I think this is middle school where you learn to divide fractions, and just to make sure that we know kind of the procedure for fractional division here. Say, for example, I'm dividing 1/2 by 3/4. So back in the old days, right, your middle school or elementary school teacher probably taught you to keep, change, flip. So what that means is that we keep the first fraction as it is, said keep it as a 1/2. We change from division to multiplication, and then we flip the second fraction upside down. So instead of having 3/4, I would have 4/3. And so now this just turns into a multiplication problem, which, remember, we can kind of pre-reduce multiplication problems by canceling out factors in the numerator and denominator that don't necessarily need to be there. So for example, this 2 and this 4 can be reduced kind of prematurely. And so what that does is that then we multiply across, so 1 times 2 is 2, and 1 times 3 is 3, and I come out with a fraction that's already reduced. So what we're going to do is we're going to do the same thing, but now I'm going to deal with kind of these wilder fractions. Now because I'm lazy, I'm just going to cross out the word and here and turn it into a big fat division sign. Alright, so I am dividing the first fraction by the second fraction. So before I go to divide these, I'm actually going to start by factoring things. Now this first expression here, it's factorable if you're using the binomial theorem, and I know that a lot of people are skipping the binomial theorem. So just be aware that sometimes Savvas is going to whip out this binomial theorem. So make sure that you look back at like Pascal's triangle stuff on here. But if you recognize the pattern here, 1, 3, 3, 1, that is one of the rows of Pascal's triangle, which is how I knew that it would factor out like this. Alright, down here I want to have my x's first. So first I'm going to divide out a -1, which is going to turn this into x squared minus 1. And then I'm going to use a difference of squares. Alright, which gives me an x plus 1, x minus 1, like that. Alright, so here's my keep, right? So I just factored it. Now my change, I'm going to do, I'm going to go from division to multiplication. And then my flip, I'm going to factor this and write the reciprocal out. Alright, so this stuff in blue I'm going to be putting here at the top. And I tend to do it in one step just because it saves paper. If you need to do it in multiple steps, you do you know. So here we are, so I have an x and an x. My plus falls down. And to get a negative here, I need opposite signs. So what multiplies to 4 that subtracts to make 3? That's 4 and 1. And then this stuff, again, because I'm flipping, is going to go to the bottom. Now with this, I'm going to have an x and an x. And with the 2 pluses, I'll have 2 pluses. And what multiplies to 4 that adds to make 5? Well, that's also 4 and 1. So here is our really nice set of fractions. Again, where I kept this one the same, I just factored it out. I changed to multiplication, and I flipped this fraction upside down. So now I'm just going to look for common factors that I can get rid of. So I see my x plus 4s. I see an x minus 1. Now I'm going to change this 3 to a 2, so I'm borrowing one of these x plus 1s to get rid of that x plus 1. and then I'm going to change that 2 to a 1 to get rid of that x plus 1. So there's still one x plus 1 here in the top, and there's still a minus 1 in the bottom. So let's go ahead and take inventory. So here at the top I just have an x plus 1 to the first power. Down here I have a negative 1. Now we don't like leaving it as a fraction if there's nothing actually down here. So I'm just going to distribute this negative 1 and call it negative x minus 1. So there's that division problem. Now you probably won't see very many division problems that require you to remember Pascal's triangle on there to factor. Most of them are like the triads that you see here. So first thing, let's go ahead and let's factor these. Here I could factor out an x, so this is going to turn into x times x plus 9. Here these are backwards, right? So I'm going to factor out a negative 1, and then I'll have an x minus 6. And here I see a GCF of 3x, and so that'll leave me with x minus 6 here. So now I'm going to do my keep change flip. So my keep, I'm going to keep it in this factored form. Oops. I'm going to change from division to multiplication, and then I'm going to flip this fraction upside down. So the 3x times x minus 6 comes to the top, and the negative 1 times x minus 6 comes down here to the bottom. And so now I need to start canceling out the stuff that matches. So the x minus 6 are pretty easy to see. And then I have an x and an x here. I canceled that out. It just missed a couple times. So here we go. So up here in the numerators, all that's left is a 3. And down here in the denominator, I have a negative 1, and then I have an x plus 9. Now there's a couple ways where you could deal with this. I like to put the negative just with the coefficient like this, but you could also distribute that negative 1 to the parentheses. Really, it just depends on what you would see there. All right. Now, in terms of the domains here, all right, remember our domain is going to be restricted based off of what is in the denominator of the fraction. And so it gets a little confusing because then we have to figure out, like, you know, which set of the fractions am I using? Am I going to do it before I keep change flip? Am I going to do it after I keep change flip? And so we really have to think about just kind of when we need to analyze it. As we've seen in the previous examples, we know that you don't want to reduce your domain after you've cut out fractions. And so then the answer lies in, do we do it, you know, do we do it before we keep change flip, or do we do it after we keep change flip? And the answer is you do it before the keep change flip. All right, so I'm going to be finding the restrictions to our domain based off of these values. So my domain is all real numbers except x equals, let's see, I can't have a 0, or else this one would be a 0. I can't have a negative 9, or this set of parentheses would be 0. And I can't have a positive 6. So there's our domain. Alright, let's try part B. So again, I'm going to start by factoring. There's just one thing to factor here, which is this numerator. So I'm going to factor out the GCF, which is 2x. And so now I'm going to do my keep change flip. So this first fraction stays exactly as it is. I change from division to multiplication, and then I flip this fraction upside down. So now what I'm doing is I'm looking for the common terms that I can cancel out. So I have my x plus 5s, and I have my x minus 6s. So in my numerator, all that's left is 2x. And in my denominator, all that's left is a 1. So I don't have to put 2x over 1. I could just call it 2x. So now for my domain, I'm going to do this one in set notation. It's all values of x, where x belongs to the real numbers, and x cannot equal. Alright, and again, I'm actually going to come and look at this after I keep change flip. So I misspoke. Up here, I have to do it for the values where I do my keep change flip. My bad, that's right here. And so my restrictions here would be -5 and 6. And so that kind of messes people up, right? Because, you know, what about up here where I keep change flip as well? So that's going to mess up kids as well. So just be aware, I'm restricting the domain here when I did my keep change flip, like afterwards. And so that might be a good note to put like to the side here. So restrict your domain after keep change flip. So there we go, guys. That is dividing rational expressions. Until next time.